Today on Engine Power, our SuperFlow dyno gets a massive upgrade in order to keep us on the leading edge of high-performance engine testing technology.
We are going to show you the entire upgrade process and, of course, test it out with one of our serious pump gas performers.
Hey everyone, welcome to a very special episode of Engine Power. Today we have our 7.3 liter Godzilla on the dyno, but we are actually not upgrading this engine, we are upgrading our dyno system. That's right, we are getting a brand new control system from SuperFlow. It's gonna give us a ton of cool functionality, and we are very excited to get it installed.
And we are excited to show you the entire process. We're getting a whole new console, a whole new operating system, a new sensor box with increased sensor capability. But before we can do that, we're going to show you the guys from SuperFlow that's going to make it all happen. Sean, Cajun, thanks for coming in.
Sir.
Nice to meet you. Thank you.
Yeah, so you guys have a lot of boxes here. It looks like a lot of cool stuff. Tell us about the upgrades we're going to be doing with our system.
Okay, there's a lot going on here today. First of all, with this system, you're getting a brand new sensor box, brand new console. You're going to be getting our new auto throttle as well, where you can do both manual and fully automated testing. 8 new channels of Lambda, you know, and a lot more cool stuff.
Oh, yeah.
Yeah, so now this is tailored for us. Tell us a little bit about that.
Correct, yeah. So we have new valves, we have new box, we have a whole lot of new goodies for you guys. Really, this is going to bring you guys up to a modern system. We're going to be getting rid of your Windows 7 computer. We're going to be putting on a Windows 11 computer, and that's all part of the upgrade from WinDyn3 to WinDyn5.
Okay, so before we do any of that, we have to make some pulls on our current system. Tell us why we have to do that.
So we do that to ensure that the mechanicals are running good on your dyno. If it runs really well on WinDyn3 it will run really well on WinDyn5.
Okay, very good.
Awesome. Well, we have a 600 horse Godzilla as a baseline, so we'll get some temp in her and then we'll make a few pulls. All right, we're gonna run the engine just like we did last time, 3,500 to 6,500 at 300 per second.
How many runs do you actually want?
3 would be great.
All right, we'll do at least 3. What a nice engine.
That controlled real nice.
Yep, 596.4, 552 pound-feet, exactly what it should be.
Yeah, from a control standpoint, what do you think, how it sounded?
Yeah, your data looks great. I think it sounds good. I think we can work with that.
Okay.
Cool,
We'll
awesome.
make a couple more here just to say we did. And,
Yep.
and we've never ever had a control issue with this.
No,
it's always
so-
worked great, so we don't expect anything crazy.
Oh, just back it up again.
Nice.
Yeah, there we go, 554, 597.
Biggest thing with dynos is consistency, right?
Correct.
Dyno's a tool, and you use it for tuning. If you're trying to do things that you're changing parts and you're trying to see if it made a difference, whether it's good or bad, the consistency of the dyno is the most important part.
Yeah.
Yes.
Especially dealing with like temperatures and sensor readouts and things. That's what's great about having, you know, all the data hack that we have and all of that stuff we're going to add. That's going to be huge for us, just tuning in engines and having consistent data to work off of. So I think this is awesome. And we'll do one more and be ready to go. Right there.
You just made 3 extremely close overlaying graphs.
Yeah.
So
Yeah, those look really good.
yeah.
Yeah, I mean, that's I don't know who built the engine, but it's pretty solid. No, but yeah, like he said, we've never had any issues, and it just works. I mean, you just lay into this thing time after time, the dyno just eats it up. So
Yeah, that makes us feel good because, you know, we always want the difference to be the parts, right?
Yeah.
And how it's done. So the dyno just tells your story. That's all it does. You know, it does exactly what you ask it to. It just tells what you've done.
Yep. We have enough data there. I think we'll get her shut down and we'll get started.
I'm good with that.
All right.
Cajun and Sean dive right into the upgrade, and with almost all of the electronics on the dyno being changed, they immediately started getting our new components out of the packaging and prepped to be installed.
The first thing to go from our WinDyn 3.2 setup is the entire console, computer, and even the desk with a little extra weight,
Out with the old.
since all are being replaced with new components. Our new desk can be raised or lowered, so we can stay on our feet as we run in and out of the dyno making adjustments, or stay sitting for extended testing periods.
And we're ready to put the console in.
This new console gets mounted to the desk and it houses our new auto throttle controller that eliminates that long cable connection that had to run inside of the dyno cell. We are also increasing the number of monitors to 4, with each one being individually configurable and allowing us to display a massive amount of live data, which we love.
With our new computer system in place, up next, Cajun gets cooking on the upgrades inside our dyno cell. All right, we have moved inside the dyno cell, so we're gonna start switching stuff out. First thing you do is get all these connections off of our sensor box and get it off.
The guys from SuperFlow got our new control console completely assembled and set up. So now we can turn our attention inside the dyno room for the next stage of our WinDyn5 upgrade. This box houses all the sensor electronics and control valve electronics, and the entire assembly is being replaced and upgraded.
So it looks like all the hookups are gonna be pretty easy, basically the same as all our old stuff, which I think will make it pretty smooth on the transition, right?
So yeah, this should be very easy. The bolt pattern is exactly the same on the back of the box. All the sensor connectors are exactly the same. Should go pretty smoothly.
The auto throttle actuator that controls our throttle cable is mounted to the bottom and is adjustable for different linkages and throttle sweeps.
So I'm setting up the auto throttle in manual mode right now. Going to 100%, adjusting the span, making sure that's moving, and going back to our 0 position.
The input and output connections are made and our pressure sensor lines can be installed into the new transducer ports. Along with all new sensors, we are also getting new servos that pair with a software to help improve the control of the dyno. The upper is located just above the dyno's absorber and controls the water entering the brake, and the other, the outlet, is just below the absorber. With those resealed and connected, we can calibrate the load cell on the dyno, which is what physically measures the torque output of the engine. This is a critical process for ensuring accurate torque measurement and horsepower calculation, and if left uncalibrated, can give false readings that are too low or too high.
This hanger mounts to the absorber and gives us a convenient location to apply rotational force on it. Then we can zero out the torque value in the software to remove the weight of the hanger from our reading and hang a known mass to apply a calculated torque to the absorber itself. Our weight is 204 pounds total, and since it hangs 24 inches from the center of the brake, we know it is applying 408 pound-feet to the absorber. After gently tapping the hanger to prevent any hysteresis or binding from affecting the reading, we can enter that value to calibrate the sensor in the software. Then we'll remove the weight and the hanger and re-zero the sensor in the software, which will finish calibrating the load cell.
Now we can reinstall the absorber cover, which we've modified to mount our new SuperFlow 8-channel oxygen sensor controller. This is a great option we wanted to add to our dyno to improve our analysis and tuning capabilities, as it allows us to monitor and tune each cylinder's air-fuel ratio individually. We do have to remove our dyno headers from the engine to TIG weld individual stainless oxygen sensor bunds into each primary tube, but they only need to be modified once, and then we can reap the benefits for years to come. The kit comes with a modern and easily replaceable Bosch LSU 4.9 universal exhaust gas oxygen sensor and long cable extensions for easy and clean routing that keeps them out of harm's way.
All right, Cajun, so we've finished up changing all the hardware inside the dyno cell. Let's talk about some of the software configuration you can do, because that's really where WinDyn5 shines.
Sure, yeah, like I was saying earlier, the configuration of this has just gotten a lot easier compared to previous dyno systems. For one instance, instead of having to open up a separate test editor to change your set points, you can now just double click and change your test start values and end values and ramp set points from the main screen.
So with all these sensors as well, can those be configured? Can they be moved? Talk a little bit about as far as a screen setup here, because this is a preloaded screen, but we can make our own screens, right?
Correct. This is the one that came with your guys' dyno system. So we can change these things around. We can move any of the sensors anywhere we want. We can resize them. And we're going to start by doing that by clicking Control and U. And that's going to bring up all these nice purple borders here. That allows us to click and drag things to where we want them to be.
There are a few final setup configurations that need to be done, and then Cajun can spend a good bit of time showing us through the new software to get us comfortable. This will allow us to take advantage of the new customizable features like screen setup, custom dyno math, additional inputs, and more. But pretty soon, we'll be ready to run our engine with our brand new dyno setup.
Coming up, we wrap up and test our new system. But first, we check out the foundation for SuperFlow's success on a massive scale.
Sean and Cajun are wrapping up the final details on our new dyno software, which will give us the most advanced control and data acquisition that SuperFlow offers. They have been well known throughout the high-performance industry for being the standard in dyno technology, and that quality is reflected in the parent company, PowerTest. Where we talk about dynoing engines with 500 to 1,500 pound-feet of torque, PowerTest dynos are custom designed for industrial engine applications that can produce tens of thousands of pound-feet, like the one at the Cleveland Brothers facility in Evansburg, Pennsylvania.
Cleveland Brothers is a full-service Caterpillar dealer. We have several different lines of business, which include heavy equipment and power systems. Inside the power systems division includes our truck shops, our commercial engine shops, marine, and our petroleum division. We are a full-service engine rebuild center. Our concentration is the petroleum industry, so we will do frac engines, we will do natural gas engines. Our Evansburg facility is our newest facility. It is an engine rebuild shop. So when we originally started looking for dynamometers and testing cells for this facility, we went to other dealers, other companies, and a common name kept coming up was PowerTest. So we reached out and contacted PowerTest to come and listen to what we wanted to do with our facilities. And from that moment on, it was more of a partnership than it was a vendor supplier. So we had used PowerTest at another one of our facilities for a smaller dyno. That was a pretty straightforward standard installation. So when we were looking at purchasing this facility and putting in test cells, we knew that our requirements were going to be somewhat different. So we went ahead and visited other locations that had other manufacturers of the dynamometers. PowerTest's name still kept coming up as being the best in the industry.
So PowerTest started working with Cleveland Brothers about 7 or 8 years ago now. So Cleveland Brothers in Evansburg has one of our 45X10 dynamometers as well as our H3610. Both of those test cells are outfitted with closed loop cooling, allowing them to run glycol in their engines. They also have our fuel measurement systems, evaporative coolers, as well as full water recirculation systems in those test cells.
Some of the differences between the automotive testing and the industrial engine testing on the dynos is very similar. You're doing horsepower, torque, RPM, torque stall. One of the biggest differences would be the size of our equipment. We have pistons that weigh 500 pounds. We have connecting rods that weigh 200 pounds. So if there's a problem with one of those parts, we find it in a very fast order, and it usually does a considerable amount of damage to a very expensive component. The PowerTest equipment we have is in both of our dyno cells. We have the dynamometers, the coolers, the motors. It's a complete PowerTest package, including the cooling tower outside. So at the Evansburg facility, we fully test Caterpillar engines to meet all the Caterpillar specifications, which include engines emissions. So we're able to tune and adjust the emissions as needed for these engines, so when they leave that we're meeting the engine emission standards as produced. We can test Tier 4 DGB engines and blend gas at this facility and provide all the testing results from those engines. I think the partnership that we have with PowerTest has enabled us to develop exceptional capabilities within our testing cells. PowerTest helped us throughout the entire design process. We had certain needs and desires that we wanted to highlight within our test cells, and there's data that we wanted to extract that maybe was not normally done. We were able to work with PowerTest hand in hand to resolve those issues, to provide the testing requirements that our customers and Caterpillar demand. So all the engines that come through the Evansburg facility will run through our dynamometer. We compare those to Caterpillar as-built specifications when they were tested. If they do not meet those specifications, the engines are troubleshot for why. Those are repaired, and then they are retested until they meet Caterpillar specifications as a new engine. PowerTest has been a huge asset to have for their test cells because this is the last stopping point for those engines. The Evansburg shop was solely built and designed as an engine rebuild facility. We rebuild, remanufacture, machine all the engine components in-house. Nothing leaves our facility.
When we get back, it's dyno time as we test out our innovative dyno software and the SuperFlow guys run us through all of its new features. Okay, so we have our Godzilla running with our WinDyn5 setup, and there are screens everywhere, which I love. There's so much data here. Same as before, 3500 to 6500 at 300 per second. All our other values are correct.
There's a lot of familiarity with this, right? Because of the programming and all that. It's so much more easy because it's easier to get at.
Yeah, that's true.
And then make sure you go to your constants and set your engine up.
So we got that entered in to make sure all this is right. 4,220 bore, 8 cylinders, 3,976 stroke, 4-cycle engine, so we know all that is correct. I love this giant screen.
The whole thing is it's there and it's easy to find, from barrel, humidity, air density, a running density altitude change. You know, for race car guys, that's we always look at that, right?
Yeah.
So,
yeah, well, let's make a run, and I'm really excited to see how this thing goes in and stuff. So you watch that, I'll watch this, and
I'm good.
We'll make a run. Oh, that's nice.
Live O2 trace. This is like Christmas.
Nice.
That was smooth.
Very
Did you see
much,
that? Like,
yeah.
it doesn't, like the old system would kind of go over the set RPM and then drag the engine back down to it. This is just like nicely just coming up to meet it. That was so smooth. I mean, 548.2 for peak torque and 609.5 for peak power, which is very close to the max we made on this engine when we dyno tested it the first time was, we made 610.
Made 610.
And I think it was like 550 for torque. So I would say that's extremely close.
Yeah, so we're right in there, and the shape of the curve looks extremely similar to what it did before, which tells us our control is really good on this.
Yes, the engine itself, it doesn't do anything crazy for the most part. It's the control part where the dyno is actually controlling what it's doing. And smoothing that out is obviously important because otherwise you're going to get a bunch of erroneous numbers, Yeah,
but that's the great part of having this engine as a baseline is we can compare them directly and know that, if you didn't have that, you'd be like, well, what is that? That shape of that curve, is that the dyno, is that the engine? We know it's exactly the same, which is perfect because that's what we want. So
right, we made a constant in this whole upgrade process.
Yeah.
Being that everything else is pretty much brand new, we needed to have that one thing that was our constant.
Yeah. And this data setup is sweet because we can have, like you said, 10 screens, I think, right?
Yeah, up to 10.
And so we can have our raw numbers, our data, this is so
just
easy.
Numerical data that we always look at. Yep. I'm very, very impressed. Having this is essentially a very, very new system. You've made everything so much more user-friendly and user-adjustable and user-customizable, right? So,
well, and just so you guys know too, just like your screens on your data or your main running screens, you can float these out too. So you can have multiple screens up at one point in time.
Well, there's only one thing left to do.
Keep dynoing?
You to make a run, because this is it's so smooth when you go in, and the new throttle setup feels totally different. You got to make a run here.
Let me see if I can get her figured out here.
Let the old man to the plate.
Oh my God, yeah. Do it. All right, let's see if we can figure it out here. Let me punch start. Everything looks good, and
buttons on top.
Buttons on top.
And both of them work.
Wow.
told you it was so easy Pat could do it.
It's so easy, even I can do it. Look at that.
Look at that. Look at that overlay.
And see,
Look at that.
That's what you want, right? When you're on your control and it's overlaying, because the engine itself, once the engine's thermally stabilized, it's going to be onesie twosie, right?
Yeah.
I cannot believe the amount of detail and the thought process you went from taking a system that was really, really good and just totally revamping it. This is spectacular. Hats off to you guys. You did a great job. This is a lot of engineering. It's a lot of time. I know this is a lot of years in the making. So.
Yeah, I feel like you've thought of everything. It's like all the stuff that you would want to be able to change, you can figure it's all right there.
And that's listening to your customers and saying, hey, what can we do to make it better? So,
that's
along with even the desk that goes up and down. I mean, it's the little things.
Yeah, right.
Awesome.
Well, guys, thank you very much.
We really appreciate it.
Thanks for having us.
Thank you very much. It was a pleasure, and we're gonna put this thing to the test. Every time.
Every day, pretty much.
Every day we have for us, we're data freaks. So anything that we can do, we're going to be on here and doing what we can on every engine that we have. So thank you very much.
You're welcome, and I'll be tuning in to watch.
Awesome.
Awesome. We appreciate it.